Hi, welcome to Analytics for All. This is a bonus lesson for our Python for Data Science course. This lesson will be on decorators. This is part of a two-part lesson. The first one's on closures. I'll have the link for that video down in the description. I did this. This is out of a direct request somebody sent me in the comments of one of my YouTube videos. Asked if I could do a video on uh, closures and decorators because they were having a little trouble understanding. I thought about doing one video, but I just couldn't really do it justice in one video because these are a little bit complicated. But again, if you haven't seen the closures video and you don't know what closures are, you probably really should start there before you go ahead into this video. If you've already seen the closures video, you should know I have a write-up on my website for all the videos I do here. On my website, analyticsforall.org. I will have a link down in the description for that. And again, this one is on decorators, and just to give you an idea, here's like the beginning line here is we'll call it the definition of a decorator. It's not going to make much sense, but we'll go into it and try to explain better by doing. Decorators are functions that wrap around other functions, changing their behavior without changing the function itself. I'm going to go ahead, jump over to our Jupyter notebooks and see if we can maybe come up with a better explanation than that. All right, so decorators are functions. A decorator, actually, if you took the closure, look up here, we have a function called decorator, put a nested function in there called PRN, and notice I'm returning PRN. So if you did the closures lesson, you realize this is a closure. That's what this is. It's a closure, okay? So notice the argument being passed to this decorator is a function. And I'm calling this function down here in between these two print statements, okay? Now, what function are we calling? Well, we could call any function there, but I've just made up one down here called my name. Okay, so we're just going to start by, let's run that, so that's in memory now, so keep in mind, good. We have an outer function, which takes in a function as an argument, an inner function called PRN, which prints a line, calls the function argument, then prints another line, and returns, so this is a closure, okay? Now we're just going to make a standard, this is just your standard everyday uh, function, my name, and print spin. Takes in no argument, so if I call it, it should just print my name, and that's what it does. Okay, so now we're going to create the decorator. We're going to say x dec, and we're sending it my name as the function. Notice there's no extra parentheses here. This isn't here. We don't need these. So just my name is the function, and then we're going to call x. Okay. Now it says my name is Ben Data Science. So remember, x is now a function. If you go here, if I were to go create a new line here and say type x, it's a function. So x is a function because we sent it a function, and we nested another function inside there. So our decorator function took in this function here, my name. So what happened when I ran it is we called the decorator function. Goes through here, says print my name is, and then inside the decorator function it calls this function. So that function prints Ben, and then finally prints I'm a data scientist, which happens 1, 2, 3 lines. Okay? And again, we're looking at a function. Let's make another one. Let's make another decorator. And go ahead and get some lines below so I can scroll. All right, this is called dec2, and takes in a function, has an internal function pr2, and it's going to print equal times 30, and it's going to print dash times 30 with a function call in the middle. If you don't know what this does, this just means to print the equal sign 30 times. That's a quick way instead of having to make, instead of having to do this, and this way you always know you got the right even number and stuff. So that's just a quick shortcut. Let's go ahead, create that memory, and now let's call this one. Now let's see what's going to happen. All right, Ben. All right, so again, I know what you're thinking, this is a long way to just do that. But here's where we can get cool. This is where decorators kind of have some function. It's when we start to nest them. So I wanted to see what we're going to do here. We're going to go for Y. We're going to put deck 2 on the outside, and we're going to put deck 3 in the middle and to send the my name function to it. Okay, so deck 1, if you remember, says my name, and then it calls function, data scientist. Deck 2 gives us the equals and the dashes. So we're wrapping a function inside of a function, these decorators here, and see what happens now. So it calls deck 2 first, which gives us this line. Then it calls deck 1, which or deck, which gives us this line. Then deck calls my name, which gives us this line. Then we have my name, and then here. All right, kind of cool. And I think that's the biggest bonus here of decorators is this wrapping function. Now, beyond this, instead of having to go through and make these giant nested kind of statements here, check this out. I can take this, and you know what? I'm going to do it. I'm going to change it up here. I'm going to make a new one, make a new definition. We'll call it, you know, my dog's name, and my one dog's name is Spud. Okay, like the potato, he's kind of a couch potato. But notice up here, I've got this @DEC. So what this @DEC is referring to is this guy up here. It's referring to my DEC function up top. So I'm going to, when I call this function, dog's name, it's going to call this decorator wrapper too. So look, see, my name is Spud. I'm a data scientist. Apparently my dog needs a better paycheck because he's not making much. But all right, so deck now. Now we want up here. Remember, we did this double wrapping here, this double nesting deck. We can do the same thing here. Deck 2, deck 1, and I just come back to both my name one in here. I want to put some more lines below so we can see what's going to come out. Okay, so for deck 2, let's go ahead and run it. And see, it says there, my name is Ben, I'm a data scientist. And I could, watch this, I could make that deck 1 and this deck 2 and see what happens. So it's all within the wrapping is what the decorator's main use is for here. That's the main functionality of the decorator. Now remember, closures, which a decorator technically is, closures are all about saving processor time, saving memory, that kind of stuff. Where decorators are about an easy, fashionable way to wrap stuff, a simple way to wrap things around here. So if I made another, you know, if I really quick just made another definition, you know, friend's name, and I said Antonio, another data scientist I know, actually print Antonio, and then I called it. Oh, oops, see what I did there? I gotta actually call it, would help. Tells me Antonio. Now all I have to do, if I want, I can just put, and I can put deck 2. I can put the, you know, there you go. See, it's how simple it is. And once you've done it, I don't have to keep repeating it. So if I go down here and I do my name again, because my name already has those decorators around it, it always does it, as long as they're up there. So if I, you know, let me run this again so they're in correct order, but yeah. So once you've decorated them, put that on top. And again, you can still go up here. This is still technically decorating too. You can still nest it this way, the old-fashioned way, but this is a nice shorthand method, and I think that's the biggest benefit of decorators is allowing you to kind of nest these functions within themselves and make changes to them without having to alter the original function itself. Okay. All right. Again, thank you for visiting my site. Again, this is Ben Larson with analyticsforall.org. I will put a description down in the, I'll put the link down in the description. I'll also have the link for the closure video down there. I've got plenty of stuff on my website to check out, other languages, SQL, Excel, R, do some machine learning on there. If you like this video, hit the like, subscribe button, leave me a message. Again, this video is a direct result of somebody leaving me a message, and I went through and made some videos for her because there was kind of a confusion as to what decorators and closures are, which makes sense. These are not easy concepts to understand. So again, thank you for joining me, and I will see you again.